Okay guys, we are going to do geometric sequences today. This still falls under the exponential functions because a geometric sequence is a sequence of numbers that follow an exponential pattern, okay? Like for instance, this sequence right here, 5, 25, 125, 625. Well, it's 5 times 5, or 5 squared is 5 squared is 25, then 5 to the third power is 125, or 25 times 5. Then you have 125 times 5 is 625, or 5 to the fourth power, okay? So that's what that number means. So it follows an exponential pattern. So basically, and again, it's a sequence of numbers where each term after the first term is found by multiplying the previous term by a common ratio, or the common ratio. So the common ratio here, or R, would be 5, okay, because everything's multiplied by 5. All right, so there's a formula that allows you to find any term in the sequence, which for, say, I just wanted to find like the two terms after this, I could just do that by hand and, multiply 625 by 5 and then that times 5, and I would find those answers. But say for instance I wanted to find like the 18th term, well, I would use this formula right here that says a to the n, which is the term I'm looking for, equals the first term, a1, times r, which is the common ratio, to the term n minus 1, where n is the term you're looking for, okay? So I'm not going to do that with this one, I'm going to do that with this one, but let's look at how this would look. So for instance, so a1 for here is 5. Okay, and then R is going to be 5, right? So let's move on to the second one. Now, the second one is geometric, or is a geometric sequence, but it's not exactly evident. So I need to find the pattern here, first of all, or the common ratio. The pattern you're following is also the common ratio. So what I do is I take the second term, this one, and I divide it by the first term, okay? That's what it says here. To find the common ratio, you divide the second term by the first. So what I end up with then is, so R will be -8 divided by 4, which is -2. Okay? So the common ratio, what everything is multiplied by, is -2. And it makes sense, so let's go ahead and do that. So if I have 4 times -2, obviously that's -8. Then if I have -8 times -2, that's positive 16. So it's going to go positive, negative, positive, negative, positive, negative, okay? So then if I wanted to find the term after that, it would be 16 times -2, which is going to be -32. So times -2 is going to be -32, right? And that's actually what the next thing I'm having you do, or having me do, because I'm making a video. Anyway, whatever. Find the next three terms. So that's the next one. So this is a to the 4. Okay, then a to the 5th power is, or not a to the 5th power, but a sub 5 is going to be -32 times -2, which is going to be positive 64. Okay, and then a sub 6, which is the last term we're looking for, is going to be 64 times -2, because that's our pattern. And that's going to be a -132. No, is that right? 128. I don't know why I said that. Okay. So again, it goes positive, negative, positive, negative, positive, negative, because you're multiplying by -2 each time, and you have to follow your integer rules. Okay. Now, what, for instance, if I ask you to find the 14th term? So find a to the 14th term. Okay, or the 14th term. Well, here's where the formula comes in handy. So I will write this out. So to find that, what I will do is I will say a sub 14, or the 14th term. Let me change markers. A sub 14 equals my first term, a1, which is 4, times my common ratio, r, which in this case is -2, times -2, to the n minus 1. So n again is the 14 because it's a 14th term we're looking for, minus 1. Okay. So then I'm going to simplify this part because of order of operations. I do exponents first and parentheses first. So parentheses actually first. I'm going to do 14 minus 1, which is 13. So I have negative 2 to the 13th power times 4. And then negative 2 to the 13th power is a big number. It is negative 8,192. Use a different color. Negative 8,192. Yes, you may use a calculator with this. And then times 4. Okay, so the final answer there is going to be negative 32,768. Okay, and that is the 14th term in the sequence, and that is where the formula comes in handy because it allows you to find any of the terms. Now, another thing you may be asked to do is to determine if a sequence is geometric or not. Okay, and the way you do that again is you would take the second term divided by the first term and then see if the numbers follow that pattern. Okay, so like say, let me actually just give a different example. I can erase this. So say I had, this number 3, 2, 4, 6, 8, 10, 12. And I look at this and I say, well, okay, well, I do 4 divided by 2 is 2. 4 divided by 2 is 2. And then I multiply 4 times 2 is 8. So I can tell right off the bat that this is not geometric. This is actually an arithmetic sequence because 2 is added to each number and not multiplied. Okay? All right, that's all. You'll just need to take notes, obviously, and complete your assignment for today.